Hi everyone, my name is Yingtong. I'm going to present our work on Mousse. This is a joint work with my collaborator Hsin-Wei and my advisor Ardalan and Sani. Before I introduce Mousse, I'd like to talk about the background of the problem Mousse is trying to solve. It is a system for selective symbolic execution of programs with untamed environments. So what are programs with untamed environments? To answer this, let's first define a program environment. A program may interact with other components in the system during its execution. We define those components as a program environment. When doing analysis like symbolic execution, people can either model or virtualize the environment if it is simple. However, when the environment is complex, like device drivers and customized hardware, it cannot be modeled nor virtualized. We refer to such an environment as untamed environment. Programs with untamed environments are quite common in the real world. OS services, software frameworks for accelerators, and customized applications are three examples. Moreover, a study conducted by OpenSignal shows programs with untamed environments are growing. As you can see, analyzing them is becoming really important. In our work, we focus on selective symbolic execution to do this. It is a way to specify which parts of a big program should run concretely and which ones should run symbolically. We introduce Mousse. It is tailored for programs with untamed environments, achieving three important goals, which are using real environments, high performance, and ease of use. Let's now briefly talk about the Mousse solutions. The first one is process-level SSE. It composes the program and the SSE engine into one OS process and run the OS process directly on the device with the environment to do analysis. This solution makes Mousse easy to use. To use it is like simply launching an OS process on the device. It also uses real environments. However, this solution alone cannot fully satisfy this goal. That's why we need environment-aware concurrency as our second solution. Here's one example to illustrate how it works. Assuming the left side is the program's execution tree, at first only path 1 is executing. Then the program sees a predicate on a symbolic variable. The SSE engine forks another process to execute path 2. Now both of them want to issue an environment called A, in other words, equal A to the environment. However, without expecting multiple concurrent equal A from user space, the environment may see conflicts and returns an error. To solve the problem, we added a component called environment-aware concurrency. It simply answers a question, is this equal A allowed in the process? In this case, for path 1, the answer is this equal A is allowed. But for path 2, it is rejected to keep the environment consistent with path 1. This solution and process-level SSE together make using real environments realistic. It also improves performance by allowing multiple concurrent paths to finish correctly. However, to execute more paths, we need another solution, which is distributed execution. In distributed execution, one device can offload the path that cannot be executed on itself to the server. Then another device can download the path from the server to finish its execution. Distributed execution and environment-aware concurrency together help improve Mousse performance greatly, as I will show later in our evaluation. Now let's talk about evaluation. We conducted experiments on 5 Android OS services of 3 smartphones to evaluate Mousse performance, code coverage, and analysis results. Here's one of the experiment results. We tested 2 APIs of the auto provider service in Pixel 3 by using environment-aware concurrency and distributed execution together. For the first API, the improvement on execution time is 84%, and for the second API is 73%, which both show great improvement. For more experiment results, please refer to our paper. To conclude, we introduced the Mousse, a system for analyzing programs with untamed environments using SSE. It outperforms alternative solutions in terms of performance and code coverage. It also opens the opportunity to perform various analyses on programs with untamed environments. Mousse is open sourced in the hope of benefiting the community. Thanks for listening. I'll be happy to take questions.